Namaste, Sada Vatsale Matarati. Hello friends. Namaste, all of you. Namaste everyone. I am myself, Takalakar, your students, Hindi teacher. Dear friends, I wish you have a self-resisting day today because it is necessary to maintain yourself. You have to maintain your body, your health, your wealth, and your study and your mind. Okay. Dear friend, in chemistry also there are certain solutions which maintain the pH and what is known as buffer solutions. The bumper is the term used in vehicles which protects the vehicle, which maintain the vehicles from the mechanical shock, from the accidental shock. Okay, so that is the bumpers. Similar fashion, the buffers works in chemistry. Okay, so what are buffers? Consider the buffer solutions. Buffer solutions. These are the solutions. The solution which maintain or which resist to change the pH. Okay, which do not going to change the pH. Okay, which maintain the pH of solution. What it means? That is it resist the change of solution when addition of small amount of strong acid or strong base. Okay. Even though we add a strong acid or strong base, the pH remains constant. Okay, that means there will no change in H plus ions or original size. And such a solutions are superior buffer solutions. Okay, so here, if you consider their types, so there are certain acidic compounds. What are acidic compounds? By the definition, it is the mixture of weak acid. Okay, acidic buffer is the mixture of weak acid and its salt in aqueous medium. Okay, so the weak acid and its salt. Okay, in aqueous solution. Oh, if you consider the example. So one of the weak acid, for example, HCl, okay, or KCl, or acetic acid, or formic acid, are weak acids. Okay, if you consider weak acid, that is the CH3COOH plus its salt with in aqueous medium with strong base. Okay, in aqueous fluid. Aqueous solutions are considered. Now, so here the acetic acid and its salt with strong base. For example, what are the strong base? For example, NaOH, KOH are the strong bases. So here the CH3COOH plus NaOH. What will be the salt? The neutralization reaction taking place. CS3CO18 plus H2. Okay, so this is the salt. Or the CS3 potassium acetate, sodium acetate. Okay, and the weak acid. Okay, now, so in this case, the weak acid plus the its salt with strong base, for example, sodium hydroxide, sodium acetate is formed, or potassium hydroxide is formed. So this is the one of the example. Okay. Or one more examples are also there. HCl. Okay. How it is formed? HCl. Okay. So here it may be this is a weak acid. Okay. Plus HCl. So this question, this is salt. This is salt, and this is a weak acid. Okay. So weak acid will reacted with potassium hydroxide. Okay. KOH. Okay, strong base. So here OH minus and this H plus going to come H2, and this is the K and this Cl. So this is the buffer solution, acidic buffer solution. Okay. Then friends, this is one of the example. Now buffer solutions is the solution which maintain the pH of the solution, or that is, it resists the change of pH of solution, when addition of small amount of strong acid or strong base is taking place. Okay, and this property is known as buffer action. Buffer action. So what is buffer action? That is the property of buffer which resists the change of pH of solution. Okay, pH of solution. Okay. So yeah, this property is known as buffer action. We are going to study how the buffer action, the mechanism of the buffer taking place. Okay. So this is about the acidic buffer. Okay. Now consider somewhat the basic buffer. So this basic buffer, it is a mixture of weak base and its salt with a strong acid. What are the weak base? For example, ammonium hydroxide weak base. When this ammonium hydroxide reacted, okay, this is a weak base, and its salt of this ammonium hydroxide with a strong acid. For example, the hydrochloric acid, HCl. So when it reacted, NH4Cl. Okay, so this Cl is from HCl, or it NH4 NO2. This is for NO2, or NH4 sulfate. This is from HCl. So here this is from the strong H2SO4, etc. Okay. So this is the salts of a weak acid and a strong base. Okay. So consider one of the example here. Then how these mixtures or these acidic or basic buffers, they maintain the pH even though the addition of the acid or base taking place in a proper quantity, in a small quantity. consider buffer mechanism or buffer action. What it means? Case 1. Now, what is there? Now, in solution we consider first there are this equilibrium CS3COO aqueous giving the acetate ions plus this ions. Okay. It is there. Okay. As well as this acetic acid is also there. Okay. Now, if we consider case 1, if acid or H plus is added, acid is added. So this acid, then what happens? So what is expected? If acid is added, then H plus ions will be more and pH becomes less. Okay, pH becomes less. Because as you know, we are going to study pH scale. Less is the pH, there will be more concentration of H plus ions. Now H plus ion is added, H plus ions increases, pH going to decrease. But it is not taking place. pH still remains constant. Why? How? Consider. So here, these H plus ions are added, then they reacts with this one with acetate ions. That means CH3CO minus plus H plus. Okay, giving the CH3COH. This is all ionized because weakness. These are weakness. Okay. Unionized. So in this case, H plus ions are utilized. Okay, and the solution not becomes acidic. That means its basicity resolved. Okay, listen these words again. Its basicity is resolved. Okay. So here one can write here. Here the basicity of solution is reserve due to is acetate ions. Okay, so these are responsible to resolve. Okay, resolve the basicity. Now consider second condition. Second, case 2. If OH minus, that is base, is added, then it reacts with acid. That is, this is the acetic acid is there. Okay, it is a mixture of acetic acid plus OH minus giving you, so this hydrogen and this alkali from the alkali. Okay, added. Then what you form? Acetate ions are formed, H2O is liberated. So in this case, even though base is added, the solution not becomes basic. It remains as it is. pH not changes. That means its original basicity or original acidity here remains constant. So here, reserve acidity is due to acetic acid. Okay, this reserve acidity is due to the acetic acid, whereas the reserve of basicity is due to the acetate ions. Okay. So in this way, the pH, thus pH not changes, not changes. Okay. So this is the buffer action. Now, if you consider the basic buffers, so what is it? This is the example. It is a weak base. This is a weak base. Okay, base. And it is salt. Okay. In aqueous medium, of course, in aqueous solution, that is solution in water, there will be this ammonium hydroxide chloride NH4 NH4Cl aqueous giving the NH4 ammonium ions plus Cl. Okay, so this is the ionization part, this is the solid, and this is the also there is weak base also there. Okay, so here this is a mixture. Okay, this is a basic buffer. Now, what is the action? Okay, consider case 1. Mechanism, buffer mechanism or buffer action. How pH remains constant in a buffer solution. Okay, so here case 1, if small amount of H plus, okay, acid is added, that is H plus added. So what happens? The acid reacts with base, there is a base. Therefore, then, okay, then NH4 OH, this is the base, plus the H plus is added externally. What is taking place? Of course, as this is the base, acid reaction taking place. NH4 ammonium ions plus H2 is formed. And again here, the H plus ions are utilized. pH not decreases, acidity not increases, because of the addition of H plus, that is pH not decreases and pH remains constant. Okay, so here even though the addition of acid, the basicity is not changes. So reserve basicity is due to this ammonium hydroxide small. Okay, reserves. Also consider one more case. If base is added. Okay, this is added with OH minus added. Okay. So what happens then? What happens? This base, okay, for example, OH minus reacted with, because there are ammonium ions and Cl minus ions, this OH minus reacted with ammonium ions. Okay, then NH4 ions from the copper reacts with hydroxyl ions added externally, forming this is the unionized base is formed. And again, the basicity not increases. That means these ions maintain the reserve acidity. Okay, so here reserve acidity is due to ammonium ions. So in this case now, very important thing we are going to study here, acidic buffer as well as basic buffer. Here the name basic buffer, so there will be, what are there? The weak bases there, depend upon the Kb value. Okay, Kb value, that is ionization constant for the weak base. How much it dissociated, the its pH can be depends, and how much salt is there, that is the concentration of ammonium chloride is there. If there are more number of NH4 ions here, then it absorbs OH minus and it tries to maintain the pH. Okay. Similarly, if there is more ammonium hydroxide with base, then again it absorbs or it reacts with added H plus and it maintains the pH. So amount of NH4OH, that is the concentration of weak base or concentration of salt here, it gives the NH4. The pH or pOH depends. Okay, so here if you add OH minus ions or if you add H plus ions, then what is the resultant? Okay, resultant. So it is explained by Henderson's equation. So according to the Henderson's equation, or which this equation relates the pH of a solution and concentration of the salt and base in this case, or the concentration of salt and the acid in the acid bucket. Okay, now consider this one. So what is that? So according to the Henderson equation, for this is known as pH, because this is the acid. Weak acid is used here. Okay, weak acid is used here, and therefore this is a weak acid, and therefore the pH is considered. Okay, is equal to pKa plus the log to the base 10, the concentration of salt, molar concentration of salt to the acid. pK. Or in this case, here the pOH is considered because there is a weak base. Okay, this is the weak base. And here, similar to this equation, the pKb plus log to the base 10, the ratio of molar concentration of a salt to the molar concentration of a weak base is considered. So this is the Henderson's equation. Now consider one by one. If more is the concentration of salt, more will be the pH. So here pH is directly proportional to the salt concentration. Also, what is about the acid? This is important. Weak is the acid or concentration. Consider one case. Second case. If low concentration of acid, lower is the concentration of acid, so this term will be high. Okay, this term will be high and pH will be high. Okay, pH increases. Okay, lower the concentration, higher will be pH. Okay, pH will be higher, increases or higher. So what it means? pH higher, that means less acid. What it means? Less acid. pH higher, that is always less than 7. Always less than 7. For the acid, pH of acid is from 0 to 7. 7 has a neutral solution. We are going to explain it later on. Here pH, consider again, lower this concentration, it means this term total, okay, this ratio will be high, and therefore this term is high, that is pH is higher. Okay, pH higher, that is less acidic. So here lower the concentration of acid implies less acid. Okay. Or if you consider pKa, what is about the pKa? By reaction minus log of Ka. Minus log of Ka. What is Ka? If you consider Ka is the equilibrium constant of the acid. Okay, weak acid. So here equilibrium constant of the acid Ka is more. That means more will be the dissociation, stronger, slightly stronger, comparatively stronger. The acid gives the more H plus ions and gives the more H plus ions, but this is the negative sign here. So here pKa value decreases. So pKa is inversely proportional to K. Okay, more will be the K, less will be the pKa. So here, if you consider for a weak electrolyte, weak acid, weak acid that means less H plus. Okay, weak acid giving less H plus. Okay, that means if Ka value is less. Okay, that is K is less. That means pKa is high. Okay. Less Ka or weak acid. So if pKa value is high, here it becomes higher and pH becomes higher. What is it? Therefore pH lower. pH higher means what? That is less acidic. Higher the pH, less acidic. So here weak the acid, it gives less H plus. That means K is less. Bro. So here the K is less and pK is higher because definition. So keep in mind, for weak acid or for concentrated acid solution and weak acid are different. Okay, so here concentration, okay, quantity to property, and this weak electrolyte, it's the nature of that acid. Okay, keep in mind. Even though whatever is the case, weak concentration, smaller concentration or weak electrolyte, the pH will be more. Okay, and the similar concept can be applied for pOH. Okay, let us consider the one more type. One more type of the buffer solution. Single salt buffer solution. It is possible. Single salt solution. Third type. Single salt buffer aqueous solution. Okay. Example. What is it? Single salt is the salt of weak acid and weak base. For example, ammonium hydroxide plus acetic acid giving the ammonium acetate. Single salt. Consider. Single salt can be able to maintain the pH. How? Look at it. In aqueous media, we have this ammonium acetate giving So at equilibrium they are acetate and ammonium. Now if we consider case 1, okay, if small amount of acid, okay, H plus ions are added, then these H plus ions they are reacted with the acetate ions and giving you unionized. This is the unionized. Okay, and again the pH maintained. Okay, so here the basicity reserve of basicity is due to the CH3CO minus ions. Now consider second case 2. If small amount of the base is added, OH minus is added, then what happens? Then what happens? The OH minus ions react with NH4. NH4 aluminum ions. Externally added OH minus ions giving a weak base. This is a weak base. Anion. Okay. So here also this is the weak salt, weak acid. And again pH is maintained. So in this case, the base is added, basicity, solution not becomes basicity, its original acidity reserve. That means here reserve acidity is due to ammonium ions in single salt copper solutions. Okay. Dear friends, we are going to study in more details about Henderson's equation and pH scale. Okay. Now, what is the pH scale? Let us study the pH scale. pH scale. Very important. There is always questions at any exam. At NEET or JEE exam, there is always questions on the pH scale. pH, pOH, Henderson equation, and copper action, copper solution, Henderson equation, like this. Now, here if you consider for going to pH scale, consider ionic product of pure water. Pure water. I know H2O may give small ionization is possible and at equilibrium. It is found at 25 degrees Celsius. That is 298 degree. Absolute scale is considered always the concentration of H plus ion concentration, and okay, it is always there, same to OH minus ion, and it is equal to 10 raised to minus 7 or 10 raised to minus 7 moles per liter. Okay, this is the molar concentration. Moles per liter. Okay. So in this case, if you consider the H plus ion concentration plus OH minus ion concentration. Okay, we are going to study across. Okay. Now consider at equilibrium. Consider this equation. The equilibrium constant is equal to H plus OH minus ion concentration and H2. This is the constant generally. So here K into H2O is H plus ion concentration and OH minus ion concentration. Okay. This is LMS constant, so it is replaced by some another constant called as ionic product. Ionic product of water is equal to H plus OH minus ion concentration. And at 25 degrees Celsius, it is found that the ionic concentration of H plus ion is 10 raised to minus 7 and OH minus is 10 raised to minus 7. Both are same. Okay. So here we can write here this is equal to 10 raised to minus 7 multiplied by 10 raised to minus 7 is 10 raised to minus 14 moles per liter. Okay. Now, if you consider the pH scale, the concentration of H plus ion or OH minus ion, okay, how it is expressed simple form, and for this pH scale is used. So in a pH scale, the concentration of H plus ion or OH minus ion can be expressed practically. It is very simple to study. Now, in this case, what happens? What is the effect of temperature on the this H plus ion and OH? The concentration of H plus and concentration of OH minus. So very important statements I am going to write here. As temperature increases. Okay, for pure water only. For pure water. Then what happens? Both H plus and OH minus concentration increases similarly. So what it means? Always there will be H plus ion and OH minus ion concentration, and if you increase the temperature, concentration increases, but there are same concentration of both. Therefore, their pH not changes. Okay, pH not changes. So here we are going to study what is meant by pH and what is the pH scale. Okay. So here the pH scale, that is the concentration of H plus ion or OH minus ion can be expressed as in the form of scale. Practically, and it is called as a pH scale. So yet you know here, I am going to write here, this word is very important. Okay, H plus and OH minus ions are constant for pure water, and the Kw equal to 10 raised to minus 7, 10 raised to minus 7, 10 raised to minus 14. Okay, not very important, but H is equal to this OH minus concentration of this C, and here this is already open here, 4.900 10 raised to minus 4 divided by the concentration is given to you 0.01 mole. So here this can be thus 4.9 10 raised to minus 4 divided by 1 into 10 raised to minus 2. So here is the answer 4.9 10 raised to minus 2. Okay. So what is the unit? Of course, degree of hydrolysis has no unit. Okay. So here this means okay. Percentage of hydrolysis is equal to 4.8 into 10 raised to minus 2 into 100. Okay, because become 2. H into 100. Okay. Okay. Also, here there are two methods. This is the one method. Also another method by addition of -1 plus 1. Okay. Okay.